I'm currently waiting for some PCBs to turn up for the other projects I'm working on. And rather than sit around idle while they are being shipped over, I decided to start work on another project. And this video is an introduction to that project. No, it's not this. Anyone that's been into old computers for a while will recognise this. It is of course a ZX80, or at least what's left of one. And this was designed in the very late 1970s, released very early 1980. And it was a kit-based personal computer in effect. Very limited functionality, but it ran a Z80 processor. Now, at exactly the same time that this was designed and released, there were other ventures underway to design entries into the computer world. And it was a time when the computer systems that were being designed varied a huge amount in terms of their performance and their target markets. Now, of course, this was aimed at hobbyists. It wasn't intended as a professional machine, as is very clear. But the interesting thing is that using exactly the same processor, you could get a massively more expensive machine. I'm talking about machines that cost maybe 500 or more times as much as this one. But the performance was off the scale compared to this. Of course, when we're looking at comparing this with professional versions of computers at the time, it's very unclear as to exactly how to go about making a comparison. So I'm not really trying to compare this with other machines at the time. I'm just really showing the sort of spread that was available. So with that said, what I'll do is I'll get the machine that I'll be working on in the next project onto the bench. We'll have a quick look at it. I'll explain what it is, and in the follow-up videos in that project I'll go into repairing and testing it. Okay, so this is the machine in question, and as you can see, it is a Cromemco System3. So obviously very much bigger and heavier than the ZX80, hugely more expensive, but it was a completely different market it was aimed at. Now, this was released very shortly before the ZX80, just a few months. Uses, or initially used, exactly the same processor, Z80. So the fundamental performance of the processor was about the same, but the system overall was of course much more capable. And it came with several options. So the System3 was a bit of an odd machine in terms of what it actually was. It's easier to think of the System3 as just the chassis, and what you could do is specify different options for it. So I think they had 6 options initially, and the way that it was sold is you would buy the System3 and specify various options. As they became available, they were added to the availability list. So initially it ran a version of Fortran and Z80 Basic, and later Cromemco released their own version of what was effectively a CP/M system, which Cromix, and also you had kind of a Unix-like operating system as well that you could select. So you had several options for what you could actually run on this, and then that capability expanded and you could ultimately run CP/M on it. It's fundamentally an S100 based machine. So the System3 was really nothing more than a chassis, and you just selected the cards that you wanted to fit into it. So it was extremely expandable. So if we look on the back, you'll see that it's got space for a lot of expansion connectors, and you can have quite a few 25-pin D-types. There are spaces for BNC connectors, and you can see that it's a very substantial piece of metalwork. It's 1/8-inch thick steel. It's extremely heavy, weighs about 25 or 30 kilos. It's actually on casters, but extremely nicely made, very over-engineered for what it is. but it was kind of its time. It's one of these engineering machines that was designed at a time when no one really knew which direction computer systems were going to go. So this was designed kind of as an attempt to future-proof the company's investment in this technology. Quite interesting the way it's assembled mechanically. We will take it apart. I haven't tried switching this on yet, and I don't actually know which cards this has in. I think the owner did tell me when he dropped it off what it had fitted, but it was some time ago and I can't quite remember. So needless to say, this is not mine. It's something I'm looking at for someone else. And the idea is to connect this to the ADM3A terminal that we've already looked at. So this is nice in the way it's actually put together. You can hinge up on the front, and then what you have is a card rack. See, we've got some floppy drives here. You can have up to 4 floppy drives in it. And these particular floppy drives are fairly unusual, but we'll have a look at those in a future video. It's a very strange design that they used in these, but it will take different types of floppy drives. And then what we have over here is the actual card rack. Okay, so the card rack slides all the way out. It's got 21 slots, designed specifically for this machine, of course, but you can see these are really just S100 cards, so probably looks quite familiar to anyone that's seen other S100 systems. Okay, so looking around, you can see just has a few cards fitted. We've got 64K RAM, processor, and that's pretty much it. We've got the interface card, but that's really all that's in here. But it is of course very expandable, so it's very easy to expand a system like this. Sorry if you can't see too well what's going on in there. It is a bit dark, but it is a long way down into the bowels of this machine. So you can see these disk drives. Probably not clear on the camera, but the actual disk drive is nearly 18 inches long. It's very unusual in terms of its construction. But what we need to do first is look at what's down at the bottom there, and that is the power supply. As I say, I haven't tried turning this on yet, and as you know from my previous videos, I always go through systems before I try powering them up. So first thing I need to do is get the power supply out. It's quite easy to get out of these machines. Just some screws on the back, and then this entire panel can be dropped down. Or you can remove the side panels. The whole case can be taken apart. But I need to take some of it out anyway to clean it. It's very dirty inside the rear part. So first thing I'll do is get this rear panel off, and then we can start looking at the power supply and see if we can bring some life back into this machine. Okay, so I've removed the top cover. So as you can see, everything inside is nicely laid out, well over engineered, plenty of room in here to get to everything. And so the next thing I want to do is remove the disk drives. This is actually a dual drive, it's not 2 separate drives, but you can see what I meant by how long it is. It's probably half as long again as a standard 8-inch drive. So what I need to do to get these out is just disconnect the power connections on the back, and then there should be 2 thumb screws, one at the top, one at the bottom. So we've got one on the top here, let's take that out, and then there should be another one somewhere underneath, which there is. And then we should be able to slide this entire drive forward. Looks like that, sure. Actually, unusually, the rear thumb screw is still there. They're normally long gone, so I'll get the rear thumb screw out. Can't really show what I'm doing. It's tucked underneath right at the back, and as I said, it is quite a long drive, so it's quite difficult to see in there. But once it's out, the entire drive should just slide out, so that's what I was getting out, and the drive should now be free to slide forward. So I slide this forward. I need to get this out of the way. They are quite delicate. They're not standard drives, and we'll have a look at this in a future video. But I'll get this out of the way, and then we can look at getting the rear panel off completely. Okay, so I've got the drive out of the way, and what I'll do now is just disconnect all the wires from the rear panel. So we've got one here that goes through to the disk drive, that's the power to the drive. Someone's obviously been here before me. I might make a better job of tidying that up, soldering, put some heat shrink on it. This is the mains power going through to the floppy drive, and the rest of the connections are really just power. Well, it looks like it's just a fancy ribbon cable. They're just multiple connectors for power, because this thing can of course draw quite a lot of current. And then of course we have the large ribbon cable, that's the data cable for the floppy drive, and this bit at the end is the extension that would go to the second drive unit if it was fitted. So what I'll do is I'll unscrew the D-type connectors from the back of the machine. I'll leave them connected. I don't want to disconnect these cables from the electronics box. There is a guide that runs down the back that allows this tray to slide in and out. A very nice arrangement, but I don't want to take that out. There's no real value to me doing that unless I find a problem with it. I will take all the cards out of course and give those a good clean, but I'll probably leave the cable runs in place unless I need to take those out. Okay, so I'll disconnect these cables, get this off the machine completely so we can lay it flat, and then I can test this in isolation and we'll see if this all works before we start applying power to anything. Okay, so I've got the power supply completely removed from the unit. And so what we have, it's a very straightforward power supply, just of course a linear supply. We've got an input filter, a bit of an odd input socket arrangement. I'll contact the owner and see if he wants me to modify this for an IEC type connector. And then we just have a huge transformer and bridge rectifier. We have another smaller transformer, cooling fan, and then some smoothing caps and some discharge resistors. And on this side we've got yet another bridge rectifier, and the whole thing's fused, so there are sort of 4 or 5 fuses on here. If you're interested, the capacitors, 29,000 microfarads at 25 volts, that's both of these, and on this side this is 210,000 microfarads at 15 volts, so this is a huge capacitor. It's absolutely enormous. Date of inspection was the 24th of the 10th 1979, and it was tested by initials KB. So if you're watching that, Mr. KB or Mrs. KB, then it's still going, or at least it soon will be. So what I'll do here is, as I say, I'll modify this and make a bit of a better job of splicing these together. I'm not even sure why these were cut in the first place. It unplugged, so it seems a bit of a strange thing to do. Admittedly, the plug's not easy to see, but it does seem a bit of a strange thing to do. I may even replace this, these 2 pieces of wire entirely and take them right back to the transformer. And we've got another splice up here, which again is a bit of a strange one. Again, I'm not quite sure why that would have been done. So it actually looks like an addition to the system at some point, whether it was done as a factory mod or factory recommended mod, or just someone did this at some point in the life of the machine. Not quite sure. But this will of course be very easy to test. It's unlikely there's any issues with it, but with capacitors of this size of course you don't want them going off inside the machine. So we'll get this cleaned up, I'll tidy up the wiring, get it powered up, and we'll run it on the Cromemco electronic loads for 24 hours and make sure that it behaves itself. So next step, get this tidied up and cleaned. So in the next video we'll look at testing this on the electronic loads, and then we'll start looking at reconnecting this to the electronics box in the main unit and get the main unit itself tidied up. Any comments are welcome. If you've had one of these in the past and have any information or interesting stories on them, then please leave a comment.